Okay, so yesterday we were talking about acceleration. Okay, we went over the Science 10 formula that you learned last year. Okay, and then we got onto this question here, which involved us using this one, which we said requires uniform acceleration, okay, in order for it to work. Okay, because essentially this is just v equals d over t. Okay, it's average velocity times time, calculates displacement. Okay, we did this problem here, which didn't require us to do any manipulating, but we should probably look at any manipulations we might need to make with this formula. Okay, so if I wanted to solve for t, how would I change this formula? This is the one that always makes people nervous. Divide what? T. If I divide by t, though, it'll be on the bottom. If I want to solve for t, I probably want to leave it where it is. Okay, think about your order of operations rules. Is the rest of the stuff on the same side as t in brackets? So when would you do it? First, right? You do what's in brackets first. So is this, remember, we just finished saying this, that this formula really is just this. Right? If I wrote it like that and I said solve for t, what would you tell me to do? Oh, be nice. Oh, come on, that was supposed to be a joke. I said, what would you tell me to do? And then I said, be nice. It's like, tell me where to go, be nice. Okay. All right, if I wanted to manipulate this one for t, you'd just tell me divide both sides by v, right? Well, if this is all in brackets, can I just take the whole thing over to the other side all at once? It's in brackets, right? I'm supposed to do that all together and first. Okay, if I want to solve for t, that's what I do. Vf plus vi over 2 all comes over there together, and I'm solving for t. Okay? There's absolutely nothing wrong with doing that. It's really just one term. Okay? I can move a whole term by itself. All right. What if I want to solve for Vf? What do I move then? What should I move first? T. Yeah. If I divide both sides by t, then that gets rid of t, and the brackets become unnecessary. Right? Now I can start picking things out of the brackets and moving them over. All right, so probably the next thing I should do is move the 2 over, multiply both sides by 2, okay, and then subtract vi. So I'd have 2d over t minus vi equals vf. And if I wanted to solve for vi, I just flip these two. They're being added after all. Okay? I could just go 2d minus vf equals vi. Either one will work. Okay? Everyone all right with that? Okay. I would like you guys then to try these two. Okay, let's look at at least the first one here right now. So in that first one there, I've got a hound running at a velocity of 16 meters per second south, slows down uniformly to 4 meters per second south. Okay, which one's VI? The first one, yeah. Okay, so VI is going to be 16 meters per second south. VF is going to be 4 meters per second, also still south. Okay, and that happens in 4 seconds. Okay, wow, everything's 4. They do. Okay, and now we're looking for D. Okay, so D equals VF plus VI over 2 times T. That's my best formula to choose here because that's the information I have. Could I do this in like multiple steps? Absolutely. But why? And if I can do it in 1 step, why not? Okay. Is there a way to do this in 2 or 3 steps? Yes. But okay, if this is a test, do you want to do it the shortest way? Saves you time anyway. Okay. All right, so I don't have to manipulate, I just need to plug in my numbers. So that's going to be 4 minus 16, or sorry, plus 16 over 2, okay, times 4. Okay, so 4 plus 16 is 20, over 2 is 10, times 4 is 40 meters south. Okay. Everybody all right with that one? Okay, how many people have done the second one? Okay, what's the trick on the second one?
You add it, but it's going to be a negative.
Right, one of those is in a different direction. This object turns around. Okay, it's initially moving up the hill, but at the end it's moving down the hill. So one of those v's has to be negative, okay, because of that change in direction. All right, let's have a look at that one here, because that comes up a lot in acceleration, and it's one of the things you have to be mindful of. So ball's moving up a hill with an initial velocity of 3 meters per second. So vi equals, I'm going to write positive as up the hill. Okay, and a little 4 seconds later. Okay, here's a significant digit question for you. How many significant digits in FOUR? None. You'd have to have counted that. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000. That's a counted number. It's also one of the reasons we don't use this textbook. They do stupid crap like that all the time. Okay? You cannot give me a time interval in words. Okay? In physics, we don't give numbers in words. Okay? They're measured values, or they're supposed to be. Okay? This time must have been counted somehow, maybe a pendulum or something, I don't know. Okay? But they counted it, so it's not going to affect our significant digits. Okay? So we're just going to write time, 4 seconds. Okay? It's moving down the hill at 9 meters per second, so that'll be our VF. That's going to be negative. Okay, find the displacement. So once again, I don't have to manipulate. That's nice. Okay, but I do have to keep in mind that one of my velocities, the final one in particular, is negative in this question. So negative 9 plus 3 divided by 2. Okay, times 4. Right, so negative 9 plus 3 is going to give me negative 6. Negative 6 over 2 is 3. Negative 3 times 4 is 12 meters downhill. If I did my mental math, yeah. Okay. Would I accept that answer? The one they have as their answer? I would not. That's wrong. Did the question give you positive and negative? The question gave you uphill and downhill. Therefore, your answer needs to have the same vectors as the question, uphill and downhill. Here's another question for you. Is uphill and downhill the same as up and down? Up is straight up. Down is straight down. Uphill and downhill are different, okay, than up and down. I know that seems incredibly picky, and it is, but it's also how it works. Okay, so make sure you specify, even if you're dealing with an uphill and a downhill, that you say uphill, not up. Okay. All right, questions on those two? All right, so like I said, that positive negative thing, that comes into in acceleration all the time, so it is something you need to be mindful of. Sometimes what I do in a question like that is I just start out and I go positive equals up, negative equals down, hill. Okay, just so I remember the end. Okay, then I got to convert it back. Okay. Let's have you write that one down and see if you can figure out which formula. So write down the question, the givens, and which formula you think we're going to use for that one. Okay, so on this one here, we've got a ball that's initially traveling at 25 meters per second. Right, so what did they just give me there? Initial speed, actually, because they don't give me a direction on that. Okay, so that's going to be initial speed, 25 meters per second. It hits a sand trap and slows down with an acceleration of negative 20 meters per second squared. Okay, acceleration is always a vector quantity, so it has to have that vector on it. All that's doing, though, is telling us that it's slowing down. It's not, giving us that it's, like north or south or anything like that. Okay. Now, the last thing is we're supposed to find its displacement after 2 seconds. Okay. What formula do I have that has those 4 things in it? Chris?
D equals VI times T plus 1 half AT squared.
Right. Okay, So we talked about that formula yesterday, just briefly, and we said that's the formula that calculates the area under the line on a position versus time graph. Okay, so we're looking for, like after 2 seconds, basically, like the graph might look like this, right? And there's where it is at 2 seconds. So, okay, we're looking at keeping the area of this and the area of that possibly, right? So we've got our initial velocity, we've got our acceleration, and we've got our time that we're using twice. Okay, so do I need to manipulate for this one? No, I just need to plug it in. Okay, so we're looking for displacement. VI is 25, okay, times 2 seconds, plus 1/2 times negative 20, important to remember that negative in there, times 2 squared. Okay, so we're going to have 25 times 2 plus 0.5 times negative 20 times 2 squared, 4. All right, so that thing is going to move 10 meters, and it came out positive. It did ask for displacement. Do I need to put the positive on there? I do. If I don't, it's a distance, and it did ask for displacement. Only vector I can give is positive. It doesn't give me anything else in the question other than positive and negative, right? So all I can say in this one is positive 10 meters. That is the extent of the vector that I can give. Okay. All right, questions on that one? Okay, now we're going to look at manipulating this equation. Okay, what are some of the other manipulations of this equation? So, D equals VI times T plus 1/2 AT squared. All right, let's start with, if I want to solve for VI. What should I move first if I want to solve for VI?
For the plus 1/2 acceleration times time squared.
Yeah, this whole side. Yeah, this here. I got to move this all over to this side. And how would I do that?
Subtract.
Yeah, I'd subtract it. Right now I'm adding that whole term. I can subtract that whole term over to this side. So I'm going to have D minus 1/2 AT squared equals VI times T. All right, I want VI by itself. What do I do with T?
You divide it.
Divide it over to the other side. Okay, now here's where sometimes people get a little bit ahead of themselves. They got a T squared on the top and a T on the bottom. Do those cancel? Not in this situation, they don't, because there's an addition operation on the top. Okay, if everything on the top was being multiplied, then yes, I could cancel those T's. But because there's an addition, or sorry, a subtraction operation on the top, I cannot cancel that T. All right, so that would be manipulated for VI. All right. What if I want to manipulate for A? What should I move first? Okay, Chris?
VI times T.
Right, subtract VI times T over to this side. Okay, how do I get A by itself? What do I do with the 1/2 and the T? Divide, yeah, that's all being multiplied together, right? If I want to do the opposite to move them, it just means divide by 1/2 of T squared. Okay, now I'm solving for A. Everybody all right with that? Same situation as well, those T's will not cancel. There's a subtraction operation on the top, so they won't cancel. Okay. All right, last one. This is the one that gives us trouble. How do I solve for T?
Like divide the 1/2 in acceleration and then move like the squared over and make it square root, or what
Okay, but I've got two t's in there. T's in two places in there.
Yeah. Oh, move that one first.
Okay? You'd have to factor it. Here's the good news. You're not gonna have to use that formula to solve for t, because we can't guarantee you've gone over that part of math 20 yet. Okay, I mean, you've done it in math 10, obviously, but, okay, you're not required to solve for t using this formula unless VI is 0. How does VI being 0 change this formula? Right, this t will disappear. Okay, if VI is 0, what's VI times 0? I'm sorry, what's 0 times t? 0. Now you could solve for t. Now it would be reasonable to expect that you could solve and move that thing around to solve for t, because all you would have to do is go divide by half of a and square root. Okay? Everybody with me on that one? You're lucky on that one. All right. Yeah, try those two. They're pretty easy because they actually both ask for D. You don't even have to do any manipulating on those two. Okay, so for number 1 here, we got skier moving down a uniform slope at 3 meters per second. Okay, the acceleration down the hill is 4 meters per second squared, and we're looking for the displacement after 5 seconds. So everything is down the hill. Don't even really have to worry about positives and negatives for this question. Okay, I can just say that VI is going to be 3.0 meters per second. Okay, that the acceleration is 4.0 meters per second squared. Okay, and the time is 5.0 seconds. Looking for D. Okay, so all I have to do is plug into the formula for this one. VI times T plus 1/2 AT squared. Okay, so we've got 3 times 4 plus 1/2. Whoops, sorry, not 4, 5. 3 times 5. 3 times 5 plus 1/2 times 4 times 5 squared. Okay, so looking at 15 and 50, 65 meters downhill. I should really stop doing that. It's a really bad habit. 60, am I right? Okay, and I have to have that vector on there. Oh, see, oh, I forgot the answer right here. Is that answer right or wrong?
Sorry, I just got a delivery for Stein. I think he left these at the table.
Thank you, Declan. Okay, so would that answer down be right? Absolutely not. Down is not the same as downhill. Okay, so that would be wrong. Okay, not specific. Okay, how many people have done number 2? All right, I'll give you a little bit more time on number 2. Remember that whole kilometers per hour to meters per second thing we learned yesterday. Divide by, what's the magic number? 3.6. Okay, divide kilometers per hour by 3.6. Okay, or multiply meters per second by 3.6. We're going the other way. Let's have a look at the second one. So the trick with the second one is just the units. Other than that, there's nothing terribly complex about it. Okay, we got to convert the kilometers per hour into meters per second. That's going to be like 27.7 or something like that. 100 divided by 3.6. Whoop, divided, not times. 3.6. Yeah, 27.7. Okay, and I'm going to keep all those decimals in my calculator because they're all going to be important. Right, on a flat road, applies the brakes at 0.8 meters per second. Now here's the, actually this is the only trick in here. What kind of acceleration do brakes provide? Negative, yeah. All right, and they do that for 1 minute, which I would convert to seconds. Okay, 60 seconds, and we're looking for the displacement. So D equals VI, so 27.7 times 60 plus 1/2 times negative 0.8 times 60 squared times 60 plus 0.5 times negative 0.8 times 60 squared. So we only have two significant figures there, so we would have 2.3 times 10 to the 2 meters. Okay, now, I'm not putting a vector on that. Why? Did the question say how far or how far in what direction? How far? How far is distance, scalar. Okay, so I don't have to put a vector on that one. It would obviously be forwards, but I don't need to say that because it didn't ask me for displacement. Okay, it asked me for how far, which is distance. Okay, so there's little things, little details like that make a difference on a test. Okay, you might have all the work right, but if you forget you didn't need forwards, okay, or this one costs people often with this formula, forgetting to make something slowing down negative, okay, and then they end up getting a number that doesn't make sense, but they write it down anyway, okay, and that's something, guys, that you really do have to watch for, especially on tests. Context matters. If you do this question, you forget to make 0.8 negative, you get an answer that says, by stepping on the brakes, you went faster. Okay, like that's something, you should look at that answer and go, wait a minute. There's something not right about this answer. The last time I checked brakes don't make you go faster. If they do, you're in real trouble. Okay, so when you look at that and you go, oh, wait a minute, that doesn't make sense, just double check. It's probably something simple. Okay, but you'd be surprised how often a mistake like that gets made. Okay, people are just like, oh great, I'm done. I'm just going to walk away from this question instead of checking to make sure their answer makes sense within the context of the question. Okay, write that one down and see which formula we might want to use for that one. All right, so on this one here, how many pieces of information am I given? 3. Okay, given 3 pieces of information here. Okay, so we have a speedboat that slows down at a rate of 5 meters per second. What do I have to remember about that number? It's negative. Okay, and it comes to a stop. What did they just give me? Final velocity, right, it comes to a stop. Vf equals 0 meters per second. Process takes 15 seconds. Okay, find the displacement of the boat. Okay, what formula has those things in it?
Would be d equals velocity or final velocity times time plus
Yeah, exactly. The one that's like the one we just used, but goes from final velocity instead. Okay? So it works like that. Vf times t minus 1/2 at squared. All right, they want the displacement of the boat. Since Vf is 0, okay, this whole term right now is 0, because Vf is 0, and 0 times anything is 0. All right, so if I'm plugging in my numbers, I got 0 minus, okay, 1/2 times negative 5 times 15 squared. Okay. Is keeping the 0 in there important? It is. I can't just eliminate it. I've got to subtract something from 0. Okay. In this case, it's actually going to end up like I'm adding it because I have a negative number inside. Okay. So 0 minus 0.5 times negative 5, okay, times 15 squared. Okay, now, does that answer make sense? They're slowing down and coming to a stop. Should their displacement still be positive? Okay. If I'm walking along the front of the classroom and then I slow down to a stop, was I still moving forward? So my displacement should be positive. Even though my acceleration is negative, I still moved forwards. Okay? Luckily, pressing on the brakes does not cause you to reverse. Okay? Because that's essentially what happened here. All right? They slowed down and came to a stop. All right, so 5, what we got here? Two significant digits, so it'll be 5.6 times 10 to the 2 meters, and we only got positive and negative here, so it'll have to be positive. I think you could also say forwards on that one if you wanted to. It's kind of implied, if not expressly stated. All right, questions on that formula? The manipulation of that going to be similar to the last one? It is, except we've got a subtraction instead of an addition. So if we're looking at this, D equals VF times T minus 1/2 AT squared. Let's say I wanted to solve for VF. What do I move first? The 1/2 AT squared by doing what? By adding it, right? So I'm going to D plus 1/2 AT squared equals VF times T, and then I would just divide both sides by T, and I'd have my solution for VF, okay? If I wanted to solve for A, what do I do? Oh.
Minus VFT.
Yep, I can subtract the VFT, I can go D minus VF times T. I just have to remember that that leaves me with negative 1/2 AT squared. Okay, if I want A by itself, what do I do with the half and the T? Divide them over. Should I take the negative with them? Yes. Okay, divide both sides by negative 1/2 T squared. That'll leave me with A. All right, and once again, you won't be asked to solve for T if VF is not 0. If VF is 0, then it would be totally valid to ask you to do that. All right. Last couple, sorry, there's one more formula we haven't done yet. Okay, give these ones a try here. Again, you got some with kilometers per hour in here, so watch out for that one. Okay, so a resting device on the aircraft carrier is the first question. Okay, so give those ones a try. All right, so on our first one here, okay, I don't know if you guys have like seen the, Top Gun Maverick or, or the original Top Gun, or both, because they're both equally awesome. Okay, but if you are landing on a carrier deck, okay, you have these cables that run across the surface of it. They're arresting cables. They're attached to big spring-loaded, steam-driven mechanisms underneath, okay, that slow the plane down, because there's no way you could land a plane and just use the brakes to stop it on the small surface that is an aircraft carrier. Okay, so it's going to stop in 150 meters, it's actually less than that, okay, at an acceleration of negative 15 meters per second squared. Is that a lot? That's more than gravity. Okay, that means that when you land and you catch that cable, you get thrown into your harness, and you would feel your harness pushing on you with a force equal to 1.5 times your weight. Okay, so it would be like 1.5 of you was standing on your chest. Okay, that's the kind of pressure that they would feel. Right, it's why fighter pilots have giant neck muscles. Okay, because they have to. They've got to move their head around under high G forces with a big heavy helmet on, but also when they're taking off and landing, it's a very violent kind of action when they do that. Right? Yeah, there's got to be like a chiropractor on board, I would think, okay, for the whiplash that you would essentially get every time you land. Okay, so we know then that the displacement of the aircraft is going to be 150 meters. That's positive because they're still moving forwards. Okay, we know that they stop. So what's VF? That's the only reason we can actually do this one, okay, is because VF is 0 and we're being asked to solve for time. Okay, and we know that the acceleration is negative 15 meters per second squared. So we're looking for the time. All right, so D equals VF times T minus 1/2 AT squared. Since VF is 0, this whole thing is 0. Okay, so I'm going to get rid of it, but I'm going to leave the negative there. So when I start manipulating, I just have to remember to bring that negative along. Right? So I want to get T by itself. So I'm going to simply divide both sides by half of A, negative 1/2 of A, and then I'm going to square root. Now, will I know if I've done something wrong here pretty quickly when I try and enter this in my calculator? If I don't make that acceleration negative, what's my calculator going to do? It's going to freak out. It literally will freak out. It'll say error, okay? Because can you take the square root of a negative number? All right, so if you forget to bring over that negative, or you forget to make the acceleration negative, if you forget both, it'll work out, oddly, okay? But you do need to make sure you have all the appropriate vectors in there. Okay, so square root of 150 divided by negative 1/2 times negative 15, so that'll take care of the two negatives, and you'll be taking the square root of a positive number. Okay, so 4.5 seconds to two significant digits. Okay, everybody all right with that? So a little bit of manipulation, a little bit of algebra there, little details to keep in mind. How many people have done number 2? Okay. So with number 2, we got to do those metric conversions again. 160 kilometers per hour is 100 miles an hour. Okay, if you're wondering, that's a very fast car. Okay, so it's going to accelerate to 160 kilometers per hour. Okay, so 160 divided by 3.6 to get it in meters per second is 44.4 repeating. Okay, took 6.2 seconds. There are lots of vehicles that can't get to 100 kilometers an hour in 6.2 seconds, so that's like equally impressive. Okay, 6.2 seconds and travels 220 meters. All right, during that time, find its acceleration. All right, so this one is also going to require us to do a bit of manipulating. All right, so we'll have d equals vf times t minus 1/2 at squared. I'm looking for a, so the first thing I want to do is bring the vft over to this side. All right, so I'm going to have d minus vf times t equals negative 1/2 at squared, and then I'll divide both sides by negative 1/2 of t squared, okay, and that will leave me with the acceleration. So when I punch in my numbers, that's going to be 220 minus 44.4 times 6.2, okay, divided by negative 1/2 of 6.2 squared. Okay. So probably the trickiest of the manipulations there, I would say. So 220 minus that number there times 6.2. Okay, and then divide that number by negative 0.5 times 6.2 squared. All right, so I get an acceleration there of, to two significant digits, 2.9 meters per second squared. Okay. Everybody all right with that? And that should be positive, okay, I would say, or, oh, it said north. Sorry, north is in the question, so north would be my vector. Okay. All right, questions on these? All right, is this really the only thing you really have to be able to do here? Read the question and do algebra? Okay, that's really what it comes down to. Okay, be able to interpret the context of the question so you get what you need, and then be able to do the algebra. Okay, that's what this all really comes down to. All right, I've got a few here that I want to put up and see how we do. I'm not going to tell you which formula is required. You're going to have to figure that out, okay, and go from there. Oh, sorry, we still have this formula. We haven't done this formula yet. Let's do this one. Okay. So this is the last formula, so we'll just kind of walk through this one. So bullet accelerates the length of the barrel of a gun, which is 0.750 meters, so it's a rifle, okay, with a magnitude of 5.35 times 10 to the 5 meters per second. Is that a massive acceleration? It is, but it has to be. Okay? A bullet goes from rest to, in some cases, 3 times the speed of sound, okay, before it exits the barrel of the gun. So it's got a lot of accelerating to do in 0.75 meters. Okay? So it's going to have a massive acceleration. Okay? With what speed does the bullet exit the barrel? All right, so here's the things we know for sure. We know this number for sure. Okay, D is 0.750. Okay, we know this number for sure. A equals 5.35 times 10 to the 5 meters per second squared. Right? And we know that we're looking for the speed it exits the barrel, so we're looking for VF. Okay? And that's all the numbers they outright tell us. What's the number I have to get from the context of the question?
The bullet starts from rest.
Yeah, that the bullet starts from rest. Okay? They don't outright say that in the question, but they also don't outright say the person who shot the gun was running when they did it. Okay? So we would have to assume, in order to do this question, that the initial velocity of the bullet was 0. Okay? Because unless you're actually carrying the weapon and running with it, it would be at rest. Bullets are not moving around inside the gun when you pull the trigger. Okay? So we would have to say that VI equals 0 meters per second. Okay, so that means then that I'm going to be using the last formula on our formula sheet that we haven't done yet. Whoop, not equals. This one. Okay. Most common mistake using this formula, forgetting that VF and VI are squared. Okay? People forget that sometimes when they write this one down and then they miss that step. So I'm looking for VF. Okay? So VF, if I want to calculate it, I actually do have to manipulate this to get VF. What do I have to do to it? Square root the whole thing. Yep. Okay, so I'm still going to leave that VI squared in there. I'm square rooting the answer basically, okay, when I get done. Okay, so 0 squared plus 2 times the 5.35 times 10 to the 5 times 0.75 meters. Okay, so square root. Square root of 2 times 5.35 E5 times 0.75. Okay. So the bullet exits the barrel of the gun at 896 meters per second. Is that fast? Well, to give you an idea, sound travels through air at 330 meters per second. This thing is traveling, well, almost 3 times that fast. So here's a thought you can rock yourself to sleep tonight with. Would you hear the bullet that kills you? No.
I mean, depends where you shot.
It depends, yeah, I mean, if it's point blank, yes, okay, but like at distance, okay, if somebody's sniping you, no. Okay, the bullet arrives at its target before the sound of the shot. Okay, this is a reality that faced a lot of the like the Taliban and people like that were targeted by special forces groups during the war on terror. Is that there were lots of sniper teams out there, and they actually had like footage of like a miss. If a sniper missed, the targets would look down, okay, because they would see a puff of dirt. Okay, or they would hear the ricochet of the bullet hitting something near them. So they would look down, and then, like a second or two later, they'd be turning to look for the shot. Because then they hear the sound of the gun being fired. Okay? The sound of the shot is so far behind the bullet, okay, that they literally have time to react to the bullet hitting the ground, missing them, and then looking after the shot is heard. Okay? So, yeah. You don't want to be on the bad side of someone who's a good marksman, okay? Because you'll never know it, okay? The sound will come after you are hit, okay? And that is, well, scary, okay? Longest shot longest kill shot is held by a Canadian sniper. Okay? And it's 4 kilometers. Okay? Just under 4 kilometers. Okay? That's scary. That somebody can do that, that's scary. 4 kilometers away, okay? That's like shooting at someone on the other side of town from here, like over in Westmount from here, okay? That's crazy, okay, that someone out there can do that. Like, good that they're on our side, but still scary that there are people out there that can do that, okay? So yeah, that's a lot of acceleration. And when we start talking about projectile motion, that feat will become even more impressive, okay? Because the flight distance and the flight time means that all kinds of things need to be accounted for when hitting that shot. Wind, okay, which could change. There could be a wind going this way during part of it and a wind going this way on another part of it. Drop, okay? Every second the bullet is in flight, it's going to fall because of gravity, okay? And even on a shot over a mile, the Coriolis effect. The earth will rotate under the bullet, okay, while it is in flight. Yes, okay? So there's a lot of things, like if one of those expert snipers, if they're going to make a long shot like that, that they have to take into account, okay? It is not by any stretch an easy feat, okay, to hit a target at that distance. Okay, questions on that formula? Okay, let's just quickly look at the manipulations of that formula. It's pretty easy to manipulate, but all right, so we got VF squared equals VI squared plus 2AD. So if I want to solve for VI, minus 2AD, yep. Okay, and then what? Then square root, so VF squared minus 2AD square rooted would give me VI, yep, definitely. Okay, if I want to solve for A, subtract VI squared. Okay, so I'm trying to get A by itself. What do I do with the 2 and the D? Divide them over. Yep. Okay, so that would solve for A. If I wanted to solve for D, it would be 2A instead of 2D. Okay? Everybody all right with that? Right, so that's all the algebra to do with acceleration that you will have to do. Okay. Let's have you try just question number 2. Don't worry about question number 1. Okay, question number 2 uses the formula that we just did, but you do have to convert those kilometers per hour to meters per second. So this one has to do with on-ramps. I have always a little rant about on-ramps. Okay, so on-ramps are designed so that motorists can move seamlessly into highway traffic. So when you go around and you're on an on-ramp, you have to depress the pedal on the right. That's the one that makes you go faster. And you must get up to highway speed before you merge. I don't know what it is out here, but I don't know how many people try and merge onto Highway 2 at 65 kilometers an hour. Yeah. Okay, sorry, I'll calm down. Okay, so yes, none of you are going to do that, right? Because if I'm behind you, I'm going to be right behind you. Okay? I will be that guy. You'll be looking at the big blue oval in the mirror. Okay? All right. So we are going to increase our speed from 50 kilometers per hour to 100 kilometers per hour. So VI, 50 kilometers an hour in meters per second. Okay, so 50 divided by 3.6 is 13.8 repeating. Okay, and we know that this one is 27.7 repeating because we already did that one a little while ago. Okay, and the maximum acceleration is 3.8 meters per second squared, which is somehow faster than the Corvette question we just did. What advantage do you get on an on-ramp? Yeah, it's downhill most of the time anyway, except this one out here, which isn't. You have to go uphill. That's what makes it more difficult. okay? 3.8 meters per second squared, okay? And we are looking for the minimum length of the on-ramp, which means we're looking for D. So VF squared equals VI squared plus 2AD solving for D. So I would subtract VI squared over to this side. And then I would divide 2A and leave D by itself. All right, so we will have the 27.7 squared minus 13.8 squared divided by 2 times 3.8. They're all positive because it's all forwards. Okay? So when we do that, we should end up with, what, about 1 kilometer, right? It's just under 1 kilometer? No, sorry, 76 meters, sorry, wrong one. Okay, so we are going to have the 27.7 squared, whoop, that's not right. Okay, minus that number squared, okay, divided by 2 times 3.8. Okay, 76 meters. So that on-ramp has to be 76 meters long. All right, questions on that one? Okay. So tomorrow, you can expect that your quiz will have some acceleration problems on it. Okay, the practice quiz will post at 3:20 today, same as always.
From yesterday or from today? Video installation.
Yeah, yeah, so it could be any of them, right? I mean, in the end, it's just algebra, right? There will be some acceleration questions, and then tomorrow after the quiz, we'll be working on our lab. Okay, so make sure, guys, can everyone just double check? I need at least one member of each group to have that app on their phone for tomorrow. Okay? It's free, you don't have to pay for it, but you need it on there.